our Understanding Microscopes lab. So we had two different designs of our microscope, each including two different lenses. One of our lenses was a 75 millimeter lens and one was a 150 millimeter lens. And the only really major difference between our two designs was where we placed our object. So if we placed our object within the focal length of our first lens, which was our 75 millimeter lens, this lens would produce a virtual image. And this virtual image is outside of the focal length of our second lens, which would then pick up this virtual image and produce it into a real image. And so this real image can be seen on a screen, which is just like a CCD camera. If we placed our object outside of the focal length of our first lens, it would produce a real image in between the two lenses. This caused a problem because our design, in the middle of our two lenses, the focal lengths actually overlapped. So if it was produced a real image inside the middle of our two lenses, then it would automatically be, that image would be inside the focal length of our second lens, which would then diverge and would produce a virtual image, and this can only be seen with your eyes, so you cannot use your CCD camera. The two images on the left are examples of our microscope where we placed our object outside of the focal length of our first lens. As you can see, you had to look through the lenses to be able to see the image displayed. On the right is our example of our CCD microscope, where we placed our image inside of the focal length of the first lens, and as you can see, the image is displayed on the screen, which would allow you to use the CCD camera.
Before there were digital cameras, old cameras needed a screen for the image to be displayed on. So with working with one lens, when a real image is produced, it's inverted and flipped like the image is. So if you have two lenses and the image is produced before the focal length of the second lens, a real upright image will be produced after the second lens, which will be able to be seen on the screen. And this is important for old cameras. The constraints with working with one lens when a virtual image is produced is that it cannot be displayed on a screen because you can only see it with your naked eye looking through the lens. And this is not useful for old cameras, which needs a screen to see the image. When a second lens is added, however, and the image is outside the focal length of the second lens, the image is magnified through the second lens, producing a real upright image. So it turns that first virtual image from the first lens into a real image through the second lens.
It helps to enclose the light path from an objective lens with a solid box, because enclosing the light lets only a little light through and improves the resolution of the image. The small hole blocks all of the light coming in that's not from the object, so it blocks all of the negative interference, and it lets only focused light from the object make it through, which makes the image be more less blurry, and it just improves the resolution. And then it also, a little hole, the pinhole, allows the eye to have enough light to produce a virtual image. Our first design, the two-lens microscope, where the image was inside the focal length, is required to allow a CCD camera to capture the image. We need to keep the object within the focal point of the objective lens so that the real image can be captured by the camera when it's viewed through the lens.